Okay guys, so you're going to see me look at my notes a lot on this because these problems are really hard. The last lesson of the unit is always supposed to be challenging. So I want you guys to really look at this, take your time, ask questions in class if you don't understand. All right guys, so this is 1.10. All right, so this is 1.10 honors and math 7. We're going to solve problems with rational numbers. Our essential question is, how do you decide which rational number operation to use to solve equations? You're going to see me solve one of these problems two different ways. That's why this is going to take a bit of time. Our vocab is constant of proportionality. We have to realize that the constant of proportionality is the same as unit rate. In other words, $10 per hour. The best example I can think of is that. You go through and you work. If you work 3 hours, you're going to make $30. It's constant. It keeps on going the same. The more hours you work, the more money you make. Okay, and that's what this is about. Okay, so our first example, I'm going to go with example 3 before we do example 2. Now, you have to know the order of operations here. You have to realize that when I have a -3 plus 2 25/100ths multiplied by 5, that we have to do what's inside the parentheses first. Okay, so what we do is we still write this -3 over here, and then we're going to add that to, I'm going to multiply the 2 25/100ths by 5. And like I said, I'm going to look at my notes real quick, and that is 11 25/100ths. Now, here's your visualization. We go through and we have two terms here. We're going to start at -3 and then we're going to add 11 25/100ths. So your visualization is this. I'm at -3. When I add, I go to the right. Okay, so we should know we're going to make it back to 0 and we are going to go through and have a positive number. I am adding 11 25/100ths here. So when I go through and I actually get here and it's not to scale, I get up to 0 first, and then I end up at 8 25/100ths. And that's my answer. It's a positive 8 25/100ths. That's your visualization, guys, okay? Don't try to memorize a procedure. Go through and actually visualize it so you actually understand the concept. Okay, so next. Actually, I'll step back for a second, pause it right here if you need to. You're going to need to do that a lot during this lesson, okay, guys? Pause and go through and write down everything that's on the board. Okay, so here's the next one. Now, with this one, I can solve this equation in two different ways. I'm going to show you the first way, okay? So the first way is that I'm going to do it solving by fractions. In other words, first, I would go through and turn these all into fractions. I turn 18 into a fraction by putting 18 over 1. I'm going to turn this into an improper fraction. 2 multiplied by 4 is 8, plus 1 is 9 over 4. Okay? Then I'm going to add that to 12 over 1 multiplied by a -1/2. Now I have to solve what's in these parentheses first. Now I want you to realize something. There's no equal sign here. So this is actually an expression. Until we put an equal sign with it, right here, that would make it an equation. Okay, guys? Okay, so the first thing I'm going to do is I'm going to go through and I am going to cross cancel. In other words, I'm looking across at these and I'm going, okay, I can divide 4 by 2 and I can divide 18 by 2. So this becomes a 2. 4 divided by 2 is 2. 18 divided by 2 is 9. The reason we do this is so that we can reduce the fraction before we actually multiply. Okay? Then when I bring this down, it becomes 81 over 2. Okay? And we're going to add that to, and I'm going to cross cancel again. I realize here I can divide by 2 also. 2 divided by 2 is 1. 12 divided by 2 is 6. Now I've got a negative multiplied by a positive. We've gone through that several times in other lessons. So don't forget, that a negative multiplied by a positive is a negative. So this becomes a -6 over 1. Now here, I'm going to combine signs. So I'm going to put this equals to, and then 81 over 2, okay, minus 6 over 1. Now, here's the thing. We have different rules for multiplication than we do for addition and subtraction. So at this point, I actually have to go through and have a common denominator. So I'm going to change this again. I'm writing a lot of steps here so you guys understand where we're going. And I have to go through and change this so this has a 2 also. So I'd multiply both of these by 2. In other words, it would look like this. 6 over 1 multiplied by 2 over 2 is going to equal 12 over 2. When I do that, then what that allows me to do is actually subtract the numerators. Now remember, the denominator is going to stay the same. It's 2. Okay, and when I subtract this, then I get 69. Now this is not my final answer, guys. That's an improper fraction. If the number on top is larger, then it's an improper fraction. I have to turn it into a mixed number. So I divide 69 by 2, and what I end up with is 34 and 1/2. That's my final answer when I solve this as fractions. Okay, guys? So if you need to, like I said, pause this, write this down. Okay, guys? All right, so now I'm going to go through and I'm going to solve this as if they were decimals, which is probably going to be a little bit easier. The hard part is you really have to read the directions on the Excel so that you realize, do they want the final answer as a decimal or do they want it as a fraction? And that's going to determine how you solve it. Okay, so in other words, I turn these all into decimals. So this becomes 18 multiplied by 2.25, 2 2500ths. Remember, every fraction is a division problem, so I can simply go 1 divided by 4, right, and I get 2500ths. That goes behind the decimal. The 2 just stays the same. I'm going to add this to 12 multiplied by, again, this is a negative, and then 1 divided by 2 is 0 and 5/10. Now at this point, this is when you go through and you use a calculator. I put this into the calculator, and what I get is 40 and 5/10 minus 6. And then I get the same answer, guys. It just happens to be in decimal form. 34 and 5/10. Okay, so that's my decimal way of solving it. Okay, now just like before, pause this if you need to so you can write stuff down. Ask me questions in class if you don't understand any of this. Okay, guys? Okay, so 2 ways to solve. You have to figure out both strategies, be able to solve it well. Okay, now let's go to our final one. Now this is an Excel that's really tough. And you're going to actually see me use some concepts here that you probably haven't even seen. That's what makes it so tough, but it's also why I'm including it in the actual lecture so that you guys can watch it over and over again. The first thing you should realize about this problem, well, I'll read it real quick. I've got it on the board back here. It says an object is traveling at a steady speed of 9 9/10 kilometers per hour. How long will it take the object to travel 2 1/10 kilometers, first round to the nearest integer and find the estimated answer? And that's really important to do, guys, to estimate first, so that when you go through and solve it, you can compare your actual answer that you get to the estimate to make sure it's right. And it says, then find the exact answer. Okay, so first thing you need to know is we have an actual equation we're going to use in this, and it's called distance equals rate multiplied by time. Now you're going to see me do a lot of work here, so you're going to want to make sure you pay attention. You need to listen to these lectures and then also go through and write everything down, ask questions on anything you don't understand. Now, one thing that we have not really done too much of, but you need to learn how to do this. You would memorize this formula, distance equals rate multiplied by time. But in this situation, what I have is the rate and the distance. And what I need is the time. So I isolate the variable, and I do that by balancing the equation. In other words, rate divided by rate is gone. And so I realized that the actual equation is time equals distance divided by rate. Now, what they do by an estimate is I'm going to round each of these numbers so we can get an estimate of what it would be. Okay? And I want you to watch this carefully because we're going to have to do the same thing at the very end. There's one important aspect we have to do. Okay? So, first of all, I round this. So, in other words, I need the time equals my distance. I could round to 2, right? And then my time, I round to 10. Now, what I have to do here, guys, is I actually have to go through and multiply this by 60, okay? Because this is 2/10 of an hour, but I need my time in minutes, so I multiply it by 60. So the first thing I'm going to do here is I'm going to cross cancel. I can divide both of these by 10. This is 1, this is 6, so my estimate ends up being 12 minutes. That's my time. Okay, so that's what we're looking at as an estimate. So when I get my final answer, it should be somewhere close to 12 minutes. Okay, guys? Now, this is where it gets a little bit more complicated. Okay, so instead of using rounding, we're still going to do the same thing. So time is going to equal, and then I do this equation that I found right here by balancing the equation and isolating the variable. So my distance is 2 1/10 divided by 9 9/10. Now this is what we call a complex fraction. Okay, I have a fraction within a fraction. Now here's what you need to understand, guys. This is why I keep on telling you, every single fraction is a division problem. This makes this easier to understand. In other words, what I do is I do this. 2 1/10 divided by 9 9/10. Now the first thing I need to do is go through and turn these into improper fraction. Okay, so 2 multiplied by 10 is 20, plus 1 is 21 over 10. And this is divided by 9 times 10 is 90, plus 9 is 99 tenths. Now here's the other part. We don't divide fractions. We don't divide fractions. We multiply fractions by the reciprocal. This may have been learned last year as keep, change, flip. I keep this the same, so 21 over 10. I change the division sign to multiplication, and then I flip this, the reciprocal, 10 over 99. Now at this point, I'm going to go through, before I do anything, I'm going to cross cancel. Of course, the 10s across from each other can both be divided by 10, so they turn into 1. That makes things a lot easier. Which is not so obvious is that the 21 and the 99 can both be divided by 3. You can try this out on your calculator to see where the division might happen. So 21 divided by 3 is 7, and 99 divided by 3 is 33. Then we multiply straight across. 7 multiplied by 1 is 7 over 1 multiplied by 33, 33. Now this is where we do that one step that I talked about. This is 7/33 of an hour, but they want it in minutes. Okay? This is where we use this right here. We multiply by 60 over 1. Okay? Now, when we multiply by 60 over 1, we're going to cross cancel again. We can do this both by 3's. So this is 11, 33 divided by 3 is 11, and 60 divided by 3 is 20. We can't do any more. So now I'm going to multiply and I'm going to have a larger number. And this is going to be 140 over 11. Now this is an improper fraction, okay? And they're going to actually want this as a mixed number. They're not going to want this as a decimal. So you're going to have to go through, every fraction is a division problem. So go through and divide this. And when I divide 11 into 140, let's see if I have enough room to do this. 11 into 140. So 11 goes into 14 once. Okay, so that is minus 11. We get 30. Okay, 11 into 30 goes twice. Okay, there's that 12 minutes. Remember, we're at 12, so we know we're probably pretty accurate. Minus 22 equals 8. And then I take that 8 and I put it over here and I put it over 11. So this ends up being 12 and 8/11 minutes. And that is our final answer. You can see how complicated this gets. So we can practice this more in class. We can go through, you can ask any questions you want, but I'm hoping you'll watch this, follow these steps so you can solve this problem. Last unit, guys, it's our last lesson in the unit. It's supposed to be challenging. So, good luck.